Hi, welcome to my video on the motion of a particle in a straight line. And here we're going to talk about when it's speeding up, slowing down, or neither at t is c at time, certain value of time. Speed increasing if the velocity vt and the at are the same sign. That is, both are pluses, both are minuses. The speed is decreasing if the velocity vt and at are different signs. That means the velocity could be positive, the acceleration could be negative, or vice versa. The velocity could be negative and the acceleration could be positive. And the speed is neither if the velocity is zero, because if the velocity is zero and is not moving, then the acceleration is also, so there's not increasing or decreasing. So let's just review that again. If your velocity is positive and your acceleration is positive, then the speed is increasing. I'm just going to write I-N-C-R-E. And if both velocity and acceleration are both negative, then the speed is increasing. And if the velocity is positive, the acceleration is negative, then it's decreasing. And if the velocity is negative and the acceleration is positive, that's different, it's decreasing. And last, if your velocity is zero, that means it's stopped, so it's not increasing or decreasing. That's at a maximum point or minimum point, or would occur with the particles turning. I shouldn't say maximum minimum, because maximum minimum occurs at when you have in terms of y. But this is turning left and turning right. So here we go. Let's do some examples. A particle moves along a line, a straight line. The function s of t gives the particle's position at t is greater than or equals 0. So we got the s of t equals t squared minus 10t plus 9. At 3 is the particle speeding up, slowing down, or neither. Well, s prime, the derivative, is 2t minus 10. So notice the derivative is 2t and a minus 10. S double prime is the derivative of the velocity. That's the velocity there, so that's a 2. So we want it at 3 seconds, so s prime of 3 seconds. So put 3 in. We get 6 minus 10, negative 4, so that's negative 4. And the velocity is positive, so this is negative, this is positive, so that means the speed is decreasing, because one is positive and one is negative. Now let's do it at 5 seconds. So again, we have here that we got the derivative here is 2t minus 10. So at 5 seconds, we get 2 times 5 minus 10. That's 10 minus 10, so that's a 0. So that means that if the that's s prime now, because s is here. If we put 5 in here, if we put any value of t in here, we'll get where the object is starting off at, the position on the, how far is away from 0. But we got here, so it's neither, because if the derivative at a certain time is equal to 0, then that means it's stopped at that instant, so it's neither increasing nor decreasing. So what about the derivative when it's 6? So there's the derivative. So we're s prime of 6, so we're putting 6 in here. So 2 times 6 minus 10. 12 minus 10 is 2. That's positive. And again, your double derivative is not changing. Your double derivative is 2. And not because they're both of them are 2s, because that's a plus and that's a plus of the same sign. So the speed is increasing when the time is 2 seconds. Or sorry, when the time is 6 seconds, it's increasing because the velocity, which is s prime, and your acceleration, which is double prime, both of them are same, so it's increasing. When they're different values of velocity and acceleration are different values, negative and positive that is, one is negative and one is positive, then it's decreasing. And if the velocity is 0, is neither. Okay, let's do another example. ST represents, this is t cubed minus 9t squared plus 15t plus 3 represents a particle moving along a straight line. S is the position of the line on the line in meters at time t in seconds, and t is greater than or equal to 0. At t is the particle speeding up, slowing down, or neither. Well, let's do s prime, which is derivative. So the derivative of t cubed is 3t squared. Negative 9t squared is a negative 18t. And plus 15t is 15. Derivative of 3 is 0. And so let's do the double prime now. We'll add it. So the derivative of, this is the velocity. And this is going to be the acceleration. So if we do the derivative of the velocity, we will get 6t. So 3t squared is 6t. Negative 18t is negative 18. And derivative of 15 is 0. So s prime, we want it at 2 seconds. So 2 seconds, let's sub 2 in. And we get 4 times 3 is 12. 18 times 2 is negative 36 plus 15. So that adds up to be 36, 27, so it's a negative 9. And double prime, S double prime at 2 seconds, 6 times 2 minus 18 is 12 minus 18 is negative 6. And again, the velocity Vt, which is single prime, velocity is negative. The acceleration, which is double prime at 2, that's at 2 there. I'm going to put 2 in here. Right? So both of them are negatives, so that means that the particle is speeding. Oops, if I can spell it right. The particle is speeding up, because both of them have the same signs. Particle is speeding up because there's a negative and a negative. So when both velocity and acceleration at the same time are the same signs, then it's speeding up. If there were different signs, one positive, one negative, it would be slowing down. If the velocity was 0, it would not be speeding up or slowing down, it would be at rest. Okay, that brings us to the end of this video. And again, if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.